All right, looking at Unit 4, Lesson 5, the second part, we're going to look at graphing sine and cosine functions. So if we just kind of look at our graph of y equals sine of x, again, like we often do, we can imagine that there's a 1 in front of here. Again, 1 times anything equals itself. So when I'm looking at graphing, again, that means I'm going to have an amplitude of 1. I'm going to have a height of 1. And the sine graph looks like this. It starts by going up, and then it starts curving down, goes all the way down like this, and then crosses once again. So we say that, again, because it goes, when it starts right here and goes all the way back to where it ends right here, we call this 2 pi. So it has a period of 2 pi. Now, our amplitude we already identified was 1. So again, we're going to call this 1. And then it goes down here at -1. So again, as my graph kind of moves this way, again, as I'm going, I go up to a height of 1, I go down to a height of -1, and when I get back to where it would start repeating, it is 2 pi. And so again, very similar, we've got y equals negative sine x. So again, looking at this negative, all right, instead of necessarily starting and going up, we are going to start here and go down, back around, and then up, finishing right here. So again, if I look at it, that's still got a height of 1 or -1. Again, we're going to take the absolute value. Still got an amplitude of 1, but it's negative. So it's -1. That's why it's flipped. So if we compare the two, again, I start by going down and then up versus up and then down. Again, this is a 2 pi period. And again, if I were to continue drawing it, is because then it would repeat. So again, it doesn't repeat at this point because it goes down and then it goes above. That's not a repeat, okay? It has to go all the way down and then up before it would start to repeat. Now cosine, again, notice in our two graphs with sine, we started at 0, 0. But cosine is a little bit different, okay? So when we use the cosine graph, we are actually going to start at the amplitude, which is 1, and then we are going to go down and then back up. Now it still has an amplitude or a period of 2 pi, and this right here is -1. So again, my graph of y equals cosine x, again, cosine starts by starting at 1 and then going down to -1. Now, if I wanted to graph the negative cosine of x, again, it's going to be sort of flipped or the opposite. So I'm going to start at -1. I'm going to move up and then go back down. So it still gets to the same height. It still gets to 2 pi. And then again, after this point of 2 pi is where it would repeat. So again, it'd be something like this. And then over here, it would be something like that. So sine and cosine, very similar. They have their base functions have amplitudes of 1. Their base functions have periods of 2 pi. Now, what were to happen if we change that number out front to not be a 1? Okay, now we've got an amplitude of 2. So basically, I'm going to take the graph that I had before. I'm going to graph it, again, starting at 0, okay, going up first, going down, and then back. Again, still going to be 2 pi. This is still, but this time my number is going to be 2 and -2. So that's going to be kind of the difference we have here. Whereas if I look at y equals sine of 2x, okay, that's actually going to shrink my period. Okay, it's going to make the period smaller. So I'm going to look at this and I'm going to say, all right, to find the period, I'm going to take what it normally is. I'm going to say period is 2 pi, and I'm going to divide it by b again. So we've got kind of a sine, this is going to be b of x. So I'm going to take that number and I'm going to divide it by 2, which means my new period is just 1 pi instead of 2. So as I'm graphing this, okay, notice I don't have a number out front. So again, that's going to go back to 1. I'm going to start at 0, 0. I'm going to go up. I'm going to go down. But this time, my new period is just pi. It's not going to be 2 pi. So it's happening at a quicker rate, twice as fast. Couple transformations in this one. Hold on, let me finish my idea here. So y equals sine bx, just so we can get the other sort of y equals sine bx plus c, and then plus d as well. So let's highlight this. Again, we've got a's, b's, c's, and d's. That's what we can manipulate in our function. So I can change the a value, I can change the b value, the c value, or the d value, and it's all going to shift or change your graph depending on what that value is. So here, again, I see that I have changed, I'm flipping it, and I am going to change the period to 1/2. So again, as I think about graphing or drawing my graph, okay, I'm going to say that because it's sine, I'm going to start at 0. It's negative, so I'm going to go down first and then up. Now I'm going to go ahead and do my little side work where, again, p equals 2 pi over b. P equals 2 pi divided by 1/2. Well, when I do 2 pi divided by 1/2, that really is like saying 2 pi times 2, which is 4 pi. So this point right here would be 4 pi, and again, it would change all along: 3 pi, 2 pi, 1 pi, 0 pi. So I'm looking at y equals 3 cosine 1/3 x. And again, I kind of have this base function of y equals a, whatever my trig function is, cosine b of x plus c, and then plus d. And we can alternate, or we can input these different letters to be adding, subtracting. This is how we're going to manipulate our data. So again, the amplitude is always going to be a. So again, amplitude, and it's really like the absolute value of a. Amplitude is always positive. So again, in this case, it's 3. Now, period is a little bit trickier per se, because my period, I generically take 2 pi divided by b. But again, if I look at this, b is actually 1/3, okay? B is a fraction. So when I go ahead and I try to determine, well, what actually is b here, okay? Well, I'm going to have to say b is 1/3. So I'm going to take my amplitude of 3, or my period, which is 2 pi divided by 1/3, which is when you can never divide by a fraction. So I'm going to have to do 2 pi over 1 times 3 over 1. That's going to really give me an amplitude of 6 pi. So now I'm going to go through and I'm going to say, okay, I've got a cosine function. I'm going to start up here. I'm going to go down and back up. Oop, that's pretty bad. I'm going to go down and then back up to right here. And yes, it would continue. It would continue on. And then this, because my amplitude is 3, this is going to be -3. And my period is 6 pi, which again means my halfway point right here is 3 pi. Y equals 2 sine, parentheses, 4x minus 3. Again, I notice I'm changing my amplitude, my period, and then this d is going to be kind of what you would expect. It's going to be a vertical shift, and because it's subtraction, it's going to be a vertical shift down. So as I'm going through this, okay, first I think I'm going to start with my amplitude, and normally my amplitude would be between 2 and -2. But if I need to shift that down 3, so I'm going to subtract 3 and subtract 3, my new amplitude is going to be -1 and -5. Oops. Let me get rid of this. All right, so that's going to help me take care of my amplitude. Now I've got to deal with my period. I'm going to say, all right, that new period is 2 pi divided by 4. So P equals 2 pi divided by 4, which again is just really like pi over 2. So my period shrunk quite a bit from 2 pi, what we would normally have expected it. So if I'm, again, going to draw my sine function, I'm going to start in the middle. It's positive, so I'm going to go up to -1, down to -5, and back around. And then again, all the way around is going to be pi over 2, which means halfway is going to be, and I have to split this up into all my important points, okay, all my important spots. So I'm going to say, all right, well, I know that 1 all the way, and again, maybe it's good to draw -3 here as well. Ooh, bad graph, Mr. Larson. So again, we're going to start here. We're going to go, we've got pi over 2. Half of pi over 2 is pi over 4. And then if we want to split that up, again, that's going to be pi over 8 right here and 3 pi over 8. So again, 1 pi over 8, 2 pi over 8, 3 pi over 8, and 4 pi over 8, just simplified. So I'm going to go here to here to here to here and back to here. Looking at y equals -3 cosine 1/2 x plus 5. Again, we are combining a lot of things here. Again, we've got an a value, we've got a b value, and we have a d value that's going to affect our graph. So again, I'm thinking, all right, cosine in general starts at the top and goes down. However, this is negative, so it's going to be inverted. I'm going to start at the bottom and go up. My period, again, my amplitude is -3, so that's going to give me 3. So in general, okay, again, if I'm just thinking, all right, so I know I've got something like here's 3, here's -3, but I have to apply a +5 shift. So I'm going to add 5, that's going to move this up here to 8, and that's going to move this to 2. Now let's worry about our b value. Again, 2 pi divided by 1/2. That's really like 2 pi times 2, which gives me 4 pi. So because it's -3 cosine, I'm going to start at 2. I'm going to go up to 8 and down to 2, like this. Again, my medium point, my in the middle point would be 5. So I'm going to say if I was going like right here, that would be at 5. And my tip right here. So my period is 4 pi where I started, and where I ended is 4 pi. That means that this is 2 pi right here. This would be 1 pi. And this would be 3 pi. Couple more examples, 2 more examples to go through. This is the first one that we'll do that has a shift left or right. So again, first thing I'm going to do is I'm going to try to determine my amplitude is 2. My b value, again, my period doesn't necessarily change. It's just going to be shifted to either the right or the left. And then I do have to move it up 3. So again, as I'm just sort of starting my generic graph, I know that I started from 2 to -2. I'm going to shift it 3. So that's going to bring me from 1 and 5. Okay. And so now to determine what my x value or my x is, I need to say, all right, I'm going to do x. Let's do blue. X minus pi over 2 equals 0. So that's going to give me x equals positive pi over 2. So I'm going to move this. I'm going to shift my graph to the right pi over 2 units. Now I do know still, again, my period didn't change. So my period is still 2 pi. So normally what I would do is I would go from 0 to 2 pi, right? I would normally go 0 to 2 pi. But I need to add pi over 2 to each one. So I'm going to add pi over 2. I'm going to add pi over 2. So I'm going to start my graph at pi over 2. And I'm going to end my graph. 2 pi plus pi over 2 is really like saying 5 pi over 2. 2 pi could be rewritten as 4 pi. So 4 pi plus 1 pi over 2 is 5 pi over 2. So I shifted it to the right 5. And again, it's a sine graph. So it's going to start in the middle and it's going to move up. So again, if my middle was 3, I would start here. I would say I'm going to go up and then I'm going to go down and I'm going to finish back where I started. So again, if this is 5 pi, if this is pi over 2, then my median point right here would be 3 pi over 2. This right here would be, again, pi over 2, 3 pi over 2, 5 pi over 2. This would be pi, 3 pi over 2. This would be like we already had it labeled 2 pi. So this would still be 2 pi. And then again, 5 pi over 2. Do make sure that you have to label the middle points and that maxes and the mins. Last example. Y equals 3 cosine parentheses 1/2 x plus pi minus 5. This is the most intense one we've done. We've got an A change, a B change, a C change, and a D change. So the first thing, again, I'm going to say my amplitude is 3. So, and I'm doing cosine, but I have to shift it down 5. So again, I should be at 3, -3 to get started. However, I need to subtract 5. So that's going to give me -2, -8. So my range goes from -8 to -2. And my domain is going to go, again, it's going to continue on forever. Now we're going to sort of mess around, or we're going to work with how can we figure out what our period's supposed to be. So the first thing I'm going to do is try to calculate, again, P equals 2 pi over B. B is 1/2, so 2 pi over 1/2. Well, to divide by a fraction, that's like multiplying, so I get 4 pi. So my period, how long it's going to take me to repeat, is 4 pi. But then I have to add 1 pi. So again, if we want to think about how we did it earlier, again, we're going to set it up and say 1/2 x plus pi equals 0. I'm going to subtract pi and get it on the other side. And then I'm going to multiply by 2. So my x is -2 pi. So I got x equals -2 pi. So I'm actually going to redraw my graph here. And just again, so that it can be neater. And I'm going to say, all right, so I know that my graph is going to start at -2 pi. That's what we just determined. Okay. And then my vertical shift we said was -2 and -8. Which means -5 is in the middle. I'm just going to mark my middle right here. And we are using -2 pi with a period of 4 pi. So that's going to give me, that means -2 plus 4, that's going to repeat at 2 pi. So I'm going to start at -2 and -2 pi. And because it's cosine, I'm going to move down and then back up right here. So if I were to fill these in, this right here would be negative pi. Again, 0 pi or just 0. This, well, again, wasn't a, let me try to adjust this graph here, because this should be right here. This would be 1 pi, and this would be 2 pi. So a lot of steps. Again, you've got to identify your amplitude. You've got to identify your period. You have to identify, do you shift that period right or left? And then you have to eventually graph it. And of course, again, this would continue on and on and on.